Alright, we're going to cover 2.4 and 2.5 about segments, midpoints, and bisectors. The first thing we'll learn is what a midpoint of a segment is. The midpoint of a segment is a point on a segment that is equidistant from both endpoints. And equidistant just means an equal distance. Okay, so there's an example down here. Here's line segment PQ, and M is the midpoint. It's the same distance from M to P as it is from M to Q. It's an equal distance, or it is equidistant from the endpoints. Now, the way I know it's an equal distance, I know that M is the midpoint, is not because it looks like it is. It's because of these marks right here. These are called tick marks or congruency marks. We put those on segments to show that they are congruent. And congruent just means that they have an equal measure. Well, when you measure segments, you measure by length. So that means that this line segment and this line segment have the same length. They're congruent, and I know that because of these marks. So that means M is right in the middle of that segment. It is the midpoint of that segment. A point is the midpoint of a segment if it is equidistant from the two endpoints. Equidistant from the two endpoints. And the distances from this point to each endpoint are congruent. So basically that statement is repeating the same thing two different ways, just using different vocabulary and saying basically what I already told you. You can find the midpoint of a segment that is either on a number line or on a coordinate plane. Here is how we would find the midpoint of a segment on a number line. A plus B divided by 2. You're averaging the coordinates of the two endpoints. You're adding two numbers together and dividing by 2. You're finding their mean or their average. And again, A and B are the coordinates of the endpoints. So, taking this formula, we can look down at these number lines and find the midpoints of these segments. So, find the coordinate of the midpoint of line segment FG. So, if you were to draw a line segment from F to G, what would be the midpoint? Well, F is at -3 and G is at 3, so those are A and B. We can plug those in. -3 plus 3 divided by 2. Just plug them into the formula. And -3 plus 3 is 0. And 0 divided by any number is always 0. So the midpoint in this case is 0. 0 will be right in the middle of these two segments, or excuse me, these two endpoints. It is equidistant from both of them. Now, on this one, you could probably figure it out just by counting or even just looking at it because it's so obvious. But not all of them are this easy. So it is important that you learn how to use the formula. We could have extremely large numbers, or we can get into decimals and fractions and things that make things a little bit trickier. So here's one that's a little bit more difficult, but it's not terribly difficult. We want to find the coordinate of the midpoint of line segment AB. Now, B, the coordinate is 3. But what is the coordinate of A? A is -3.5. Okay, so those are our two coordinates. Those are A and B. We're going to plug those into the formula. A plus B divided by 2. So A plus B divided by 2. Alright, -3.5 plus 3 is a -0.5. And a -0.5 divided by 2 is a -0.25. Or you could say -1/4 if you want to write it as a fraction. But the midpoint will be at -0.25 or -1/4. So if you wanted to know where that would be on the number line, this is a half. A fourth is half of a half. So it would be halfway between the 0 and the -0.5. So here would be -0.25 right about here. That would be where the midpoint is. Alright, if the coordinates of the midpoint of a segment AB on a number line is 3, and A is at -2, find the coordinate of B. So we have a segment AB. So that means the endpoints have to be A and B. It says the midpoint of the segment is 3. So there's going to be a midpoint here. We'll just call it M for midpoint. And its coordinate is 3. A is at -2, and we want to know what is the coordinate of B. Now, it is possible to use the formula here. I'm going to show you how to do it with the formula first, and then I'm going to show you my shortcut, my preferred way of doing it. Remember, the midpoint is a plus b divided by 2. Well, we can substitute the information we have in here and solve for the missing one. I know the midpoint is 3. I know a is negative 2. I don't know what b is. So it becomes the one variable in the equation, and we can solve for that variable. Now, we haven't done any equations quite like this yet, but if this entire side is divided by 2, I can multiply by 2 to get rid of that. 2 times 3 is 6. To get b by itself, I need to get rid of this negative 2, so I'm going to add 2. And I would find out b is equal to 8. And that's one way we can do it. That is the correct answer. The coordinate of b will be 8. But there is an easier way, I believe. Okay. Because m is the midpoint, it is exactly halfway from a to b. Exactly halfway. So, what is the distance from a to m? Well, from negative 2 to 3, that's a distance of 5. You have to go up 2 just to get to 0, and then you go up 3 more to get to 3. So you're going up 5. Well, remember, if m is the midpoint, these segments are supposed to be congruent. So if this is 5, this has to be 5 also. So if I start at 3 and I go up 5, where am I going to be? I'm going to be at 8. So the coordinates of b are, the coordinate of b is 8. Okay, now that was dealing with one dimension. We were working on a number line. So let's look at what we do if we're on a coordinate plane. So now we're talking about 2 dimensions. Okay, it might look a lot trickier, but what this is, the midpoint is a point on the graph. It's going to have an x-coordinate and a y-coordinate. So when we write an ordered pair, we have the x and then we have the y. So that's all this is. You got your parentheses. This is what we do to find the x value. This is what we do to find the y value. And if you look at each one of those individually, it's just a plus b divided by 2. A plus b divided by 2. The only difference here is we're doing it twice because we have 2 dimensions. We got to find the x value and we got to find the y value. So it's just like doing exactly what we've done, just doing it twice and writing it in the correct format. So we want to find the midpoint between these 2 points. Remember, every ordered pair, the first number is the x, the second number is the y. First number is x, second number is the y. Okay, remember, it does not matter which one is point 1 and which one is point 2. What does matter is that x1 and y1 come from the same point. x2 and y2 come from the same point. So I'm going to make this x1, y1, x2, y2. And technically I should say x sub 1, y sub 1, but I'm just being lazy as I talk. Alright, we're going to plug these into the formula. And I'm just going to focus on the x values first. So I got x1 plus x2 divided by 2. That's this right here. So negative 11 plus 8 is a negative 3. Now, if you like fractions, you can leave it just like that. That is simplified, negative 3 over 2. Or if you like decimals, you could write it as negative 1.5. That's the x value. Let's do the same thing for the y value. So for the y value, it's y sub 1 plus y sub 2 divided by 2. Now, we are adding a negative number. When you add a negative, you are subtracting. So we have 3 minus 7 is a negative 4. And a negative 4 divided by 2 is a negative 2. So we found the x-coordinate and the y-coordinate of the midpoint. We can write down what the midpoint is. And here is on where you will find the midpoint on the graph, on the coordinate plane. Let's try the next one. Find the coordinates of the midpoint of line segment VW if the coordinates of V and W are right here. So again, x1, y1, x2, y2, plug them into the formula. Let's find the x value. We're averaging the x coordinates. x1 plus x2 divided by 2. So 3 plus 7 is 10, and 10 divided by 2 is 5. So we got the x coordinate. Let's get the y coordinate. We're averaging the y coordinates. We add them together. y1 plus y2 divided by 2. So negative 6 plus 2 is a negative 4. Negative 4 divided by 2 is a negative 2. So we got the x coordinate, we got the y coordinate. We can write the coordinates of the midpoint now. And the coordinates of the midpoint are 5, negative 2. All right. Let's do one more of these, and this is a little bit different. M is the midpoint of line segment AB, and it gives you A, and it gives you the midpoint. And we want to find the other endpoint. So this is very similar to what we did in example 3. The only difference is we are in 2 dimensions now instead of 1. So I'm going to draw a picture. What I'm not worried about is where on the graph these really fall. I'm just drawing a straight line. You can plot it on the coordinate plane if you want to, but it's not really necessary. We got line segment AB, and M is the midpoint. Now I'm going to write the coordinates next to the letter. So A is at the coordinates 0, 1. M is at the coordinates 3, 5. And we want to find the coordinates for B. Now again, you can take the formula up here and substitute everything in and solve. You just have to do it twice. Or you can do the shortcut I showed you earlier. We just got to do it twice. So for the x value, from A to M, remember it's halfway across. And halfway across, the x value went from 0 to 3. That is an increase of 3. Remember, this is halfway across. So when it goes the other half of the way, I would expect the same change. I would expect that x value to increase by 3 again. So I'm going to take 3, add 3. I know that B should have an x value of 6. Okay, focus on the y value. From one end to the midpoint, the y value goes from 1 to 5. So what happened? It increased by 4. Well, from the midpoint to the other side then, it should increase by 4 more. So 5 plus 4 is 9. So the coordinates of B, 6, 9. All right, let's talk about what a segment bisector is. A segment bisector can be a point, line, ray, segment, or plane that intersects a segment at its midpoint. When you bisect something, you split it into 2 congruent halves. You split it right through the middle into 2 congruent halves. So if I have a 10-foot pole and I bisect it, I'm splitting it into 2 5-foot poles. I'm splitting it right down the middle. That is a segment bisector. It intersects at the midpoint. It splits it into 2 congruent halves. Okay? So on this next one, it says, use the figure below to answer examples 7 through 9. So as you're doing this, I would suggest using a pencil so that after you do example 7, you can erase that information before you do example 8. Otherwise, you might get a little confused. Now, the first thing I'm going to do, though, it says that line segment WY, right here, bisects line segment UV at Y. So that's telling you Y is the midpoint of line segment UV, and line segment WY is bisecting line segment UV. So line segment UV is like that 10-foot pole. It's getting split into 2 congruent halves. I know line segment UY and line segment YV are going to be congruent. Okay? Now let's label the picture with all the information they give us in example 7. It says the distance from U to Y is 5. And we want to find the distance from V to X, or excuse me, from Y to V and U to V. Okay, well, what's the distance from Y to V going to be? Remember, because this is the midpoint, that means that these are congruent. So if this is 5, guess what this is? It's 5. So the distance from Y to V is 5. Remember, we read this as distance from Y to V. What about the distance from U to V? Well, remember your segment addition postulate. Line segment UV is split into 2 parts, but those 2 parts should add up to equal the whole. So 5 plus 5 equals 10. So the distance from U to V, 10 units. Okay, I'm going to erase this information that was specific just to example 7 so that we can work example 8. Okay, let's relabel the picture. Now, this information still stays the same, so I already know that these segments are congruent. All right, line segment UY, the distance from U to Y is 4x minus 3. The distance from Y to V is x, and we want to find the distance from U to Y and the distance from U to V. Now, before we can find the distance from U to Y, we got to find out what x is. That's the only thing stopping us from knowing what that is what x is. Well, if we want to find x, we have to have an equation that we can solve for x. So we're going to have to set up an equation. Well, we just finished saying that we know that these are congruent, which means that they have equal measures. Anytime things are congruent to each other, you can set them equal to each other Because if this is 5, this is 5. If this is 12, this is 12. They're going to be equal to each other. So I'm going to set up this equation. This says 4x minus 3, this segment equals this one, x. So there's our equation, and we can solve for x now. Now, both sides of the equation are simplified, but we have x on both sides, and we only want it on one side. Again, you can get rid of whichever one you want. I always get rid of the smallest one. 1x is smaller than 4x, so I'm going to get rid of 1x. If you do it on one side, you got to do it on the other side. So 4x minus x is 3x. You had 4, you took away 1, you got 3 left. Bring down everything else. Now be careful here. Some people, when they do this, usually when it's x minus x, we don't write anything because there's already something else to write down that's still on that side of the equation. But if there's nothing else there, what is it? It's 0. X minus x is equal to 0. If you start with an equation, you're going to end with an equation. You can't just have one side of the equation disappear. So make sure you fill that space with a 0 if there's nothing else there. Now x is on one side. We want to get it by itself. You got to get rid of the constant first. It's being subtracted. To get rid of it, we do the opposite operation. So we still got 3x. Over here, 0 plus 3 is 3. And then we want to get rid of this 3. X is being multiplied by 3, so we're going to divide by 3. And 3 divided by 3 is 1. Now that tells us what x is, but we're not done. Our goal was to find the distance from u to y and the distance from u to v. Well, the distance from u to y was 4x minus 3. So we substitute the 1 in for x. And when we do that, 4 times 1 is 4. 4 minus 3 is 1. So we actually find out the distance from u to y is 1. So if you forgot to plug it in, you would have got extremely lucky on this problem. But we also need to find the distance from u to v. Well, we just found out the distance from u to y is 1. Remember, these are congruent. Also, this is labeled as x, which we found out is 1. So the distance from u to v, the whole thing, segment addition postulate. 1 plus 1 is 2. This whole thing will be 2 because 1 plus 1 is 2. So the distance from u to v is 2. Last one. Let's erase the information from the previous problem. Write in the new information for example 9. It says, if the distance from u to v is 18, and the distance from u to y is 9, find the distance from y to v. Well, they gave you more information than you need on this problem. You could solve this two different ways. One, we already know that these are congruent because, again, y was the midpoint. So these are congruent. If that's 9, that's 9. Let's say that they didn't tell you that uy was 9. You could still solve this problem because we know that these two parts have to add up to equal this whole. So I know this plus this equals 18. And I know these are congruent, so they each have to be half of the whole thing. So what's half of 18? 9. They have to each be 9. That's the only way they can both be congruent and add up to 18. So whichever process you go about finding it, the distance from y to v should be 9.